Welcome to the Deep Dive. Today we're going deep into cybersecurity news, all coming from the ArcSieve Research Hub.
Straight from the source.
Yeah. Published today, January 22nd, 2025. We'll be talking quantum threats to blockchain attacks.
Yeah, it's incredible to me how cybersecurity research really does mirror real-world events, the speed at which attacks and defenses evolve. It's just mind-boggling, really. So today's deep dive is going to make sure you're ahead of the curve.
All right, so let's start with something that sounds like it's ripped straight out of a sci-fi movie, post-quantum cryptography.
Okay.
Two papers that kind of stand out to me: one-time signature based on pseudorandom number generator, and the continuous logarithm in the complex circle for post-quantum cryptographic algorithms.
You know, quantum computers pose a huge threat to our current encryption methods.
Right.
Like, just imagine banking or messaging, anything that we do online, being completely vulnerable. Researchers are really working hard to develop these algorithms that can withstand the power of quantum computers.
Yeah. The first paper is proposing this new way to create one-time signatures using a pseudorandom number generator. Think of it like a digital signature that you can only use once, so it makes it virtually impossible to forge even with a quantum computer.
Exactly.
Which is crazy.
Yeah, and the second paper delves into complex numbers to create quantum-resistant algorithms. It even reimagines classic algorithms that we see like in Bitcoin, and really gives us a new perspective on security measures.
I guess the big question is like, what does this mean for our listener and their data in a few years?
You know, data that we consider secure today might be completely vulnerable tomorrow. You know, as quantum computers become more powerful, the threat just intensifies. These solutions that we're seeing are incredible and give us a lot of hope that our data will be safe in a post-quantum world.
I mean, that is reassuring to a degree.
Okay.
Let's talk about AI, a double-edged sword in cybersecurity. It can be used to attack and defend. Two papers that highlight this AML-based detection of covert communication in IPv6 and securing the AI frontier.
The first one, AML-based detection of covert communication in IPv6, really dives into how AI models are being trained to detect hidden messages, smuggled within network traffic. So imagine AI acting as a digital detective, sniffing out this concealed communication. But the problem is the attackers are evolving their tactics just as fast.
Okay.
It's a cat and mouse game.
Oh, totally. So it's an AI arms race. I mean,
Cool.
you said that securing the AI frontier takes a step back and really examines the broad implications of AI and cybersecurity and really dives into the ethical and regulatory challenges that AI faces, emphasizing bias, transparency, and accountability.
Absolutely. And consider what happens when the bad guys are using AI to launch these very sophisticated attacks. We're talking self-learning attacks that can adapt in real time. As AI becomes more integrated into our systems, making sure that those systems are secure and trustworthy is paramount.
Absolutely. Yeah. Blockchain technology is constantly evolving, and it really does have implications far beyond cryptocurrency. Let's talk about Zapdos, towards optimal blockchain latency, which showcases a new architecture designed for speed. And they have achieved something like 20,000 transactions per second with sub-second latency.
Yeah, that's significantly faster than Visa or MasterCard.
Right.
You know, this level of speed that we're seeing could completely revolutionize online transactions, making blockchain an actual viable option for everyday purchases.
Right, which is crazy to think about.
Right?
But even with these advancements in blockchain technology, vulnerabilities still remain. BRC20 sniffing attack demonstrates just that. This attack targets BRC20 token markets. These are tokens built on the Bitcoin blockchain that allow the creation and trading of digital assets. And this attack exploits the buying process itself.
Right. It's, like I said, cybersecurity is this constant game of one-upmanship.
Yeah.
Right? As these new technologies emerge, attackers always inevitably seek out these weaknesses. And so even blockchain, with its inherent security features, requires constant scrutiny and improvement.
Right? Decentralization of Ethereum's builder market challenges this assumption that builder centralization in Ethereum is harmless.
You know, this study reveals that even without majority control of what are called validators, centralized builders can wield significant power, and that really influences the fairness and security of the entire Ethereum system. And this finding raises concerns about the long-term health of decentralized systems.
Yeah, monetary evolution. How society shaped money from antiquity to cryptocurrencies provides a historical lens to examine this rise of cryptocurrency.
You know, I think this perspective is very important because it reminds us that while technology changes, the fundamental concepts of money don't really change.
Right.
And understanding this context allows us to navigate this evolving landscape of digital currency with greater insight and a better appreciation for the challenges and opportunities they present.
That's great. Cybersecurity research is constantly looking to find and address these vulnerabilities. Bridging the security gap. lessons from 5G and what 6G should do better, analyzes the security shortcomings of 5G networks.
Yeah, 5G networks, while offering these advancements in speed and connectivity, have inherent security flaws. And so as we transition to 6G, understanding and mitigating these weaknesses becomes essential.
Yeah, a review of false data injection attacks focuses on a threat to critical infrastructure.
Right. These attacks target systems like power grids manipulating sensor data to cause disruptions. Imagine hackers being able to trigger blackouts just by feeding false information into the system. This research really underscores the urgency of developing better detection and data recovery methods.
Okay. It's good that researchers are actively working on this.
Okay.
The paper, Using Hypervisors to Create a Cyber Polygon, outlines the creation of virtual training grounds for cybersecurity professionals.
These simulated environments are very important. They allow cybersecurity professionals to test their skills and practice responding to real-world attack scenarios.
Yeah.
By creating these digital battlegrounds, we can better prepare for evolving threats.
Yeah, technology is obviously crucial, but so is the human element when we talk about cybersecurity.
Absolutely. The human factor often proves to be the weakest link in the security chain.
Phishing awareness via game-based learning explores a new approach to educating users about phishing scams.
Right, traditional awareness training often fails because it's so dry and unengaging.
Right.
And so this research suggests that games could be the key to making cybersecurity education much more interactive and effective.
Okay, who are we? Power Centers and Threat Modeling takes a look at the power dynamics within cybersecurity.
Threat analysis is often shaped by the perspectives of those in positions of power, and this paper really challenges us to consider whose voices are heard and whose are silenced when we're making these cybersecurity decisions. And recognizing those power dynamics is really essential for creating a more inclusive and equitable security landscape.
That's a great point. So after all these insights, what does it mean for the average listener out there?
Well, the cybersecurity landscape is this complex and ever-changing battlefield. New technologies bring new threats, and staying ahead of the curve requires a multifaceted approach that includes technological advancements, robust defenses, and a keen awareness of the human element. Welcome back to the deep dive. Let's jump right back into some of these source material findings with a protocol for compliant, obliviously managed electronic transfers.
Okay.
This research really tackles this challenge of creating a system for secure and private digital asset transfers. Just imagine being able to send cryptocurrency without anyone being able to trace the transaction back to you.
Yeah, that sounds pretty ideal.
It combines techniques like unlinking counterparties, making transactions oblivious, and then even preventing manipulation by service providers. It's cutting-edge research with real-world implications for this future where digital assets play an even more prominent role in our lives.
That makes sense. Speaking of digital economies, the paper characterizing transfer graphs of suspicious ERC-20 tokens caught my eye.
Yeah, so ERC-20 tokens are these digital assets created and traded on the Ethereum blockchain. And this study really focuses on identifying these scam contracts within this ecosystem.
Gotcha. Ethereum is like the second largest blockchain platform out there. Why is it a hotbed for cybercrime?
Well, the anonymity offered by blockchain technology attracts scammers seeking to exploit unsuspecting users. This research analyzes what are called transfer graphs, which are basically visual representations of how tokens move around the blockchain.
Okay.
And they actually found that suspicious contracts often exhibit distinct patterns in their transfer graphs. And they were able to develop a model capable of identifying these scam contracts with remarkable accuracy.
Wow, that's super interesting. Okay, so going from that to a more traditional cybersecurity approach, the paper Towards Improving IDs Using CTF Events focuses on enhancing intrusion detection systems, or IDS.
IDS are essential for any robust cybersecurity strategy. Think of them as like digital alarm systems, right? They're monitoring network traffic for anything suspicious. But the traditional testing methods for IDSs often fall short because they rely on these known attack signatures, which is like trying to catch a thief using only the footprints from their last heist, you know?
Yeah, totally. So capture the flag events offer a more dynamic approach then.
Exactly. These competitions challenge cybersecurity professionals to solve complex security challenges in real-world scenarios.
Okay.
And so incorporating these CTF challenges into IDS testing really allows researchers to test them against these creative and unexpected attacks that traditional methods might miss.
Okay, so they're using CTFs to train the IDS in a way.
Exactly. It's like this controlled training ground where the good guys can practice against the bad guys before a real attack happens.
That makes sense. The paper, Key Concepts and Principles of Blockchain Technology, steps back and examine some of the fundamental ideas behind this revolutionary system.
Blockchain is no longer just about cryptocurrency. It has the potential to transform various industries from supply chain management to voting systems, even healthcare.
Are there downsides to blockchain, though?
While it has its advantages, there are challenges. This paper acknowledges challenges such as scalability and energy consumption. So understanding both the potential and limitations of blockchain is very crucial for its responsible development and implementation.
Right, that's a great point. Characterization of GPU-TE overheads in distributed data parallel ML training kind of combines several complex topics into one. Can you break this down?
Sure. So imagine a digital vault within your computer's hardware where sensitive data can be processed without exposure to the outside world. That's what a trusted execution environment, or T, is.
Okay, so far that sounds pretty good. What's the catch?
Well, the catch is that using TEs can introduce performance overheads, especially when training large machine learning models. And so this paper examines these costs, specifically focusing on GPU Ts used in this distributed data parallel training.
Okay. Provably effective detection of effective data poisoning attacks sounds pretty promising.
Absolutely. Data poisoning poses a significant threat to machine learning models. Imagine an attacker injecting malicious data into a training dataset, causing the model to learn the wrong thing.
Right.
This paper claims to have developed a new statistical test called the conformal separability test, and this can effectively detect data poisoning attempts. And the researchers claim a mathematical guarantee for identifying poisoning attempts, backed by experimental evidence.
Wow. Blockchain security, risk assessment, and quantum era migration strategies and proactive defense tackles the quantum threat head on.
Right. Quantum computers pose a significant risk to blockchain security. They're like these super-powered code breakers capable of cracking the encryption, protecting blockchain transactions and assets.
That's a scary thought.
This paper analyzes how different blockchain components, from networks and mining pools to transaction verification mechanisms and even user wallets, could be vulnerable to these quantum attacks. And it proposes mitigation strategies, including this hybrid migration approach to guide these blockchain systems in transitioning from classical to what is called quantum-resistant cryptography.
Wow. Okay, so this paper, FedMUA, exploring the vulnerabilities of federated learning to malicious unlearning attacks, sounds like it's a mouthful to say.
It is. It is. But federated learning is a decentralized approach to machine learning, where multiple devices collaborate to train a model without actually sharing their raw data.
Right.
Imagine training a model on medical data from thousands of patients' smartphones without actually collecting that sensitive data in one place. That's what federated learning is trying to achieve.
Okay, yeah, that sounds ideal.
But this paper actually explores a new type of attack called a malicious unlearning attack, where an attacker tries to manipulate this federated learning process and weaken the model's performance. And the researchers developed a specific attack called FedMUA that targets influential samples within this training data and causes the model to unlearn important information.
Okay, staying on this topic of attacks, BRC-20 snipping attack focuses on a specific blockchain vulnerability.
Right, so these BRC-20 token markets allow for the trading of these tokens on the Bitcoin blockchain. This snipping attack exploits this flaw in the buying process, allowing attackers to jump the queue and steal tokens from legitimate buyers. It's like digital pickpocketing.
Oh, wow. That's pretty crazy. The metaverse, with its promise of these immersive digital experiences, also presents unique security challenges. The dilemma of privacy protection for developers in the metaverse explores these concerns.
The metaverse collects so much data about its users, and this raises these privacy concerns. And this paper really focuses on the developers who are building these immersive experiences and questioning whether they're even prioritizing privacy in their designs.
Yeah, are they even thinking about it?
Right. And what they found is that while privacy awareness is growing, developer knowledge and the available support is limited. There's no clear strategies for identifying and safeguarding the sensitive data in the metaverse. And the legal frameworks are very vague and open to interpretation.
Right. Ratio attack on G plus G, convoluted Gaussian signature.
So this unveils a new attack targeting what's called lattice-based signature schemes.
Okay, for those unfamiliar, what is lattice-based cryptography?
It's a relatively new encryption method that's actually considered resistant to quantum attacks. And this research demonstrates that even these supposedly quantum-resistant schemes can be vulnerable.
Okay, that's interesting. What is a ratio attack exactly?
It's a technique that exploits these weaknesses in how signatures are generated. By analyzing the ratio of multiple signatures, an attacker can actually extract information about that secret key used to create them.
Okay, that makes sense. Application machine learning techniques for secure traffic in no-C-based minicores brings us back down to the hardware level.
Exactly. This paper focuses on the security of network-on-chip systems. It's basically a miniature internet within your computer chip.
Wow, so even our computer chips can be vulnerable to hackers.
Absolutely. These systems are becoming increasingly complex and vulnerable to attacks, particularly something called denial-of-service attacks. So denial-of-service attacks are like digital traffic jams that flood a network with bogus requests and just cripple it.
So how can machine learning help prevent these attacks then?
The researchers suggest using these machine learning algorithms to analyze the traffic patterns and identify any anomalies that are indicative of a DOS attack. It's like having a digital traffic cop inside your computer chip.
That's pretty wild.
Right?
Phishing awareness via game-based learning reminds us that the human element is always so important.
It really is. You know, phishing attacks are still a pervasive threat, and the traditional awareness training just doesn't cut it.
Yeah?
So this paper explores using games to teach people how to identify and avoid phishing scams.
Oh, that's a cool concept.
The researchers developed a serious game targeting various phishing stacks, and using a large language model, they were able to create these dynamic dialogues and questions, and it really became this adaptive learning experience. And participants who played the game actually showed a significant increase in awareness and confidence in their ability to identify phishing attempts.
Wow, that's great. Balance-based cryptography. Physically computing any Boolean function takes a completely different approach to secure multi-party computation.
Yeah. Imagine using a balance scale and coins to securely compute any Boolean function.
Are we talking about an actual balance scale like you see in a science lab?
Exactly. The researchers developed protocols utilizing a balance scale and coins to represent and manipulate data, enabling multiple parties to perform computations without revealing their private information.
That's an interesting way to look at it. BotDetect, a decentralized federated learning framework for detecting financial bots on the EVM blockchains, tackles this growing problem of bots in decentralized finance.
Right, so DeFi is this rapidly growing sector within the blockchain space, but it's also become this target for malicious bots. These bots can manipulate markets and exploit vulnerabilities. It's like having this rogue army of Wall Street traders.
Oh, wow. So how do we stop them then?
Well, this research proposes using decentralized federated learning to detect these bots. DFL allows multiple parties to collaboratively train a machine learning model without sharing their raw data. Imagine a global network of cybersecurity experts pooling their knowledge to identify and stop these malicious bots.
And they were able to actually implement this.
Yeah, they implemented their framework using smart contracts on the Ethereum virtual machine, showcasing its potential for real-world deployment. It's a fascinating example of how blockchain and AI can be combined to create more secure and resilient systems.
That is fascinating. FedClean, Byzantine defense by clustering errors of activation maps in non-IID federated learning environments.
Byzantine attacks involve malicious actors within a distributed system that are trying to disrupt its operation, by sending false or misleading information.
Right.
So in federated learning, this could mean sending corrupted model updates.
Okay.
And so this paper introduces FedClean, a defense mechanism specifically designed for these non-IID environments, which are very common in real-world federated learning applications.
What exactly is a non-IID environment?
In these environments, the data used to train the model isn't evenly distributed among participants. Imagine a medical study where data from one hospital is very different from data from another.
Okay.
So FedClean analyzes the activation maps of each client's model to really identify and isolate those that are sending corrupted updates. Think of it as like using a magnifying glass to scrutinize each participant's contribution, looking for these subtle signs of sabotage.
That's interesting. Okay, so this paper, you can't eat your cake and have it too. The performance degradation of LLMs with jailbreak defense is examining a fundamental trade-off in cybersecurity.
Right, so large language models are very powerful AI systems capable of generating human-like text, but they're also susceptible to what are called jailbreak attacks.
Okay, and what are jailbreak attacks?
So imagine turning a helpful AI assistant into this digital puppet spewing propaganda. That's essentially what attackers are trying to do with these jailbreak attacks. They're tricking LLMs into generating harmful or inappropriate content.
Gotcha. So how do we protect against this then?
Unfortunately, defenses against jailbreak attacks often come at the cost of performance degradation. It's like having to choose between security and usability. And this paper explores this trade-off by evaluating various defense strategies and how they impact LLM performance.
Right. So are there any effective defenses without sacrificing performance?
Well, their findings indicate that while some defenses can effectively mitigate jailbreak attacks, they often do so at the expense of significant performance degradation. There's no easy solution, but this research helps us understand the trade-offs involved and the need for further innovation.
All right, healthcare data is becoming increasingly valuable and vulnerable in the digital age.
Mm.
Empower healthcare through a self-sovereign identity infrastructure for secure electronic health data access.
Yeah.
Explore some solutions for secure data management.
This paper proposes a framework using self-sovereign identity or SSI principles to give patients greater control over their health data. Imagine you having the keys to your own digital health records. SSI enables individuals to manage their digital identities and their data without having to rely on centralized authorities.
So how would that work in practice then?
The researchers outline a system utilizing blockchain technology, something called decentralized identifiers, and verifiable credentials to create this secure and transparent way for patients to access and share their data. And this system could really revolutionize healthcare by empowering patients and fostering greater trust between patients and healthcare providers.
That sounds great. Library attack, reverse engineering approach for evaluating hardware IP protection sounds like something out of a spy movie.
Hardware IP protection is so crucial for safeguarding chip designers' intellectual property, but this paper reveals this new attack technique called library attack that bypasses existing protection measures.
Okay. How does this attack work?
Well, the attack really exploits this fact that many chip designs use pre-existing IP blocks from third-party libraries. And so by analyzing these libraries and comparing them to the target chip, attackers can identify and extract this sensitive design information.
Okay, yeah, that makes sense. The societal implications of blockchain technology in the evolution of humanity as a superorganism takes a more philosophical approach, exploring blockchain's impact on society.
This paper proposes that blockchain technology could significantly influence the evolution of human society by facilitating the emergence of decentralized, self-regulating systems.
So is blockchain going to turn humanity into a giant ant colony?
Well, the paper does draw some parallels between ant colonies and blockchain's potential for enabling more efficient and equitable systems of governance and resource management.
Okay.
But it's really about exploring blockchain's potential for empowering individuals and communities. It's giving them greater control over their lives and their destinies.
Right. Improving the efficiency of self-supervised adversarial training through latent clustering-based selection focuses on making machine learning models more robust to attacks.
Right, so adversarial training is a technique for strengthening machine learning models against adversarial examples.
And what are adversarial examples?
Well, imagine training a model to detect fake news by exposing it to a wide variety of examples. Adversarial training works in a similar way, but it can be very computationally expensive, especially for large data sets. And so this paper introduces a new method that utilizes what's called latent clustering to selectively train the model on a smaller subset of data. Think of it as pinpointing the most important training examples and focusing on those. And this approach significantly reduces the training time and memory requirements without sacrificing the model's robustness.
Okay, that's a good approach. Differentiable adversarial attacks for marked temporal point processes delves into a different type of adversarial attack, this time targeting time series data.
Right, so these marked temporal point processes model events occurring over time, like network traffic, sensor readings, or financial transactions. And this paper explores how adversarial attacks can be tailored to disrupt these models.
So give me an example of how this could be used maliciously.
Imagine an attacker manipulating sensor data from a power grid to trigger a false alarm or cause a blackout. That's what we're talking about here.
Right. And what makes these attacks so challenging to defend against?
Unlike image or text data, defining what constitutes an imperceptible change in time series data is very difficult, making these attacks harder to detect. And so this paper introduces this new differentiable attack scheme that enables subtle manipulation of time series data while still achieving the attacker's objectives.
Wow, Zapdos, towards optimal blockchain latency, aims to address one of the major criticisms of blockchain technology: speed.
Blockchain systems often face criticism for their slow transaction speeds compared to traditional payment systems.
Right.
And Zapdos, a new blockchain architecture, is designed to minimize latency while maintaining high throughput.
So is the goal to make blockchain transactions as fast as swiping a credit card?
Exactly. By addressing key sources of latency through a parallel pipeline architecture, they were able to achieve a throughput of 20,000 transactions per second with sub-second latency. And this could pave the way for wider adoption of blockchain technology.
Okay, that's really interesting. Jailbreaking large language models in infinitely many ways sounds like a nightmare scenario.
It really is. This paper investigates what are called infinitely many meanings, or IMM attacks. And these jailbreak attacks exploit this increasing ability of LLMs to understand paraphrases and these encoded communications to really bypass safety measures. It's like finding a secret language that can trick an LLM into performing actions it's not supposed to.
Okay, that's scary. Did the researchers find any solutions?
Well, they were able to demonstrate how these IMM attacks could bypass the safeguards of even the most powerful LLMs. They recommend enhancing guardrails and developing techniques to detect and block these paraphrases and these encoded communications. It really emphasizes this need for stronger defenses against these attacks.
Right. Explainable adversarial attacks on course-defined classifiers sounds interesting.
So multi-stage classifiers make predictions in steps, starting with a coarse classification and then refining it with these finer-grained predictions.
Can you give me a simple example of that?
Sure, think of a system that classifies an image as a cat or a dog first, and then it identifies the specific breed of cat or dog.
That's it.
And so this paper proposes this attack method that utilizes what's called layer-wise relevance propagation, or LRP, to generate what are called explainable adversarial perturbations.
Okay, so what is LRP?
Well, it helps us understand how a machine learning model makes its decisions. And so by using LRP, the researchers can pinpoint the features the model relies on and then target those features to craft adversarial examples.
What makes these attacks unique, though?
These adversarial examples are explainable, meaning we can understand why they deceive the model, and this transparency is crucial for developing robust defenses against them.
Right. Legal Guardian.
Oh.
A privacy-preserving framework for secure integration of large language models in legal practice addresses this need for data protection in the legal profession.
Yeah, LLMs hold the potential to revolutionize legal practice, but they also pose a risk to client confidentiality, especially when dealing with sensitive personal information.
Yeah, for sure.
This paper introduces Legal Guardian, a framework designed to protect client data when using LLMs.
So Legal Guardian protects sensitive legal information.
It utilizes named entity recognition, or NER techniques, to identify and mask personally identifiable information within legal documents before they're processed by the LLM. It's like redacting sensitive information before sharing a document.
Okay, GRID. Protecting Training Graph from link-stealing attacks on GNN models focuses on safeguarding training data in graph neural networks.
Yeah, these GNNs excel at analyzing graph-structured data like social networks or transportation networks. And this paper addresses what are called link-stealing attacks, where attackers are trying to figure out links between nodes in the training graph.
Okay, give me a real-world example of that.
Sure, imagine trying to reconstruct a social network solely by analyzing the communication patterns between its members.
Okay, yeah, that makes sense.
This paper introduces graph link disguise, or GRAD, a defense mechanism that adds carefully crafted noise to the model's output. This noise makes it harder for attackers to infer this link information.
So is it adding static to a radio signal?
Precisely.
Gotcha. Temporal analysis of adversarial attacks in federated learning? Sounds interesting.
This research explores how the timing of adversarial attacks in federated learning can impact their effectiveness.
So is it about finding the ideal time to launch an attack?
Their findings revealed that temporal attacks launched at specific points during training can severely impact the model's performance, especially during the later stages of training.
Okay.
This research emphasizes the need for defenses that can actually detect and mitigate these temporal attacks in federated learning.
Tell me about yourself. LLMs are aware of their learned behaviors. Explores the potential for self-awareness in LLMs.
Right. This research really investigates whether LLMs can articulate their learned behaviors without explicit prompts or examples. So they fine-tune these LLMs on datasets exhibiting specific behaviors, like making risky economic decisions or even generating insecure code. And the LLMs actually surprised researchers by accurately describing their learned behaviors, even though those behaviors were never explicitly labeled in the training data.
So it seems like the AI developed self-awareness of its flaws in a way.
While this is a possible interpretation, attributing human-like qualities to AI systems requires caution. But this research does raise some intriguing questions about learning and intelligence in AI systems.
Right. Technical report for the Forgotten by Design project. Targeted obfuscation for machine learning emphasizes proactive data privacy in machine learning.
This paper focuses on the right to be forgotten in the context of machine learning. It explores techniques for selectively obfuscating data used to train a model, making it impossible to extract sensitive information about individuals.
So you're making certain data points disappear from the model's memory.
Precisely. Targeted obfuscation allows for the removal of personal information from a model while preserving its overall accuracy and functionality.
Synthetic data can mislead evaluations. Membership inference as machine text detection highlights a potential pitfall in using synthetic data for privacy risk assessment.
Yeah. So these membership inference attacks aim to determine if a specific data point was used to train a model. And researchers often use synthetic data to evaluate these attacks because it's difficult to create these realistic non-member data sets.
Right.
But what they discovered is that MIAs frequently mistake synthetic data for training data, regardless of the model or the data source.
Okay.
So it's like the MIAs are unintentionally acting as these detectors for machine-generated text.
Right, so the data fools the attack and also makes the results misleading.
Exactly. And this research really cautions against relying solely on synthetic data for these membership inference evaluations.
Okay, OC Row Bay. Improved error-free asynchronous Byzantine agreement via partial vector agreement delves into the theory of distributed systems.
You know, Byzantine agreement focuses on achieving consensus among a group of computers, even when some might be malicious or faulty.
Right, so how does this paper help solve that problem?
Well, this paper presents a new protocol for achieving Byzantine agreement in asynchronous networks, where messages can be delayed or reordered. Their approach introduces what's called partial vector agreement, which allows for agreement on parts of a value, even if complete agreement isn't possible.
Okay, yeah, that makes sense. Shadow genes. Leveraging recurring patterns within computational graphs for model genealogy sounds like a really interesting concept.
Yeah, this paper introduces a method for identifying the architecture, type, and family of a machine learning model by analyzing its computational graph.
What is a computational graph?
It's essentially a map of how data flows through the model. Imagine a flowchart showing the steps involved in a complex calculation.
Yeah.
This research presents a technique called shadow genes that extracts unique patterns from the computational graph to create this signature for the model.
So is it like looking at the model's DNA?
Precisely. This method allows researchers to understand the model's capabilities, limitations, and potential security risks.
Cross-entropy attacks to language models via rare event simulation explores another type of adversarial attack.
Right. So this paper focuses on attacks against language models that use this cross-entropy optimization. And these attacks try to find inputs that maximize the cross-entropy, causing the model to make the worst possible predictions.
Okay. How do they find those inputs then?
Well, they propose this new attack method using rare event simulation to efficiently search for these adversarial examples. Rare event simulation is a technique for estimating the probability of events that are unlikely to happen. Think of it as trying to predict the odds of winning the lottery.
Right.
So by applying this technique, they found highly effective attacks against language models.
That's interesting. With great backbones comes great adversarial transferability. Examine the adversarial robustness of these models built on pre-trained backbones.
Yeah, pre-trained backbones are the foundation of many modern machine learning models. And this research investigates whether attacks against these pre-trained components can transfer to models built upon them.
So it's like if the foundation of a building was vulnerable, then the entire building would be vulnerable.
Exactly. And the researchers found that attacks against pre-trained backbones can be surprisingly effective, even if the attacker knows very little about the model built on top.
Wow. Measured hockey stick divergence and its applications to quantum pufferfish privacy delves into quantum information theory.
Right. This paper introduces this new measure of privacy called the measured hockey stick divergence, specifically designed for quantum systems.
Why is a new measure needed for quantum systems?
Traditional privacy measures might not accurately apply to quantum systems because in the quantum world, even observing something can alter its state.
Right.
So this new measure considers the specific types of measurements an attacker could perform.
Okay. A unified view of IoT and CPS security and privacy takes a broader look examining the security and privacy challenges of the Internet of Things and cyber-physical systems.
The IoT connects everyday objects to the internet, while these cyber-physical systems interact with the physical world. So think self-driving cars or smart power grids.
Right.
This paper provides a unified framework for analyzing security risks in both IoT and CPS.
Okay, differential area analysis for ransomware. Attacks, countermeasures, and limitations explores the fight against ransomware.
So ransomware encrypts victims' data and demands a ransom for the decryption key.
Right.
So the differential area analysis, or DAA, attempts to differentiate ransomware encrypted files from other encrypted files.
Okay.
And this paper examines DAA's strengths and limitations. It proposes new attack methods that can bypass DAA detection and then develops countermeasures to thwart those attacks.
Okay, ESS, expertise extraction, generalization and reply framework for an optimized automation of network security compliance. tackles this challenge of automating security compliance checks for computer networks?
Traditionally, security experts have manually conducted these checks, but this paper proposes ESAS-CF, a framework that leverages expertise extraction and machine learning to automate this
So
process.
are they creating an AI security auditor?
Essentially, yes. ESAS-CF enables security tools to learn from human experts and apply that knowledge to new scenarios, reducing manual intervention.
Gotcha. Our final paper for this part of the deep dive. An anonymous yet accountable contract wallet system using account abstraction explores the world of blockchain-based wallets.
Right, so the researchers propose this new wallet system that achieves a balance between anonymity and accountability.
Anonymity is often desired in cryptocurrency, but it can also facilitate illegal activities. How does this system address that?
The proposed wallet system combines account abstraction and something called accountable ring signatures. Account abstraction allows a smart contract to initiate transactions for a user, while accountable ring signatures enable verification of the transaction issuer's identity without revealing their full identity.
Okay.
Welcome back to the deep dive. Let's wrap things up by exploring this final set of insightful research papers.
Okay, sounds good. An exploratory study on the engineering of security features really focuses on the practical aspects of building secure software.
All right. This study looks into how security features are actually implemented in real-world software systems.
Okay.
The researchers interviewed experienced developers to really understand the decisions they make and the challenges they encounter when incorporating security into their work.
Right, because it's one thing to talk about security theoretically and then another to actually build it.
Exactly. And the study found that while developers often rely on pre-built libraries for security features, there's still a lot of custom code that needs to be written and maintained.
Okay.
They also found that security decisions are often influenced by time constraints, project requirements, and even team dynamics.
Yeah, that makes a lot of sense. TrustFormer, a trusted federated transformer, explores a new approach to federated learning.
Right, so transformers are this powerful type of deep learning model, but they need massive amounts of data for training. And so federated learning allows these models to be trained on data spread across multiple devices without having to centralize it.
Okay, but doesn't that introduce some privacy and security concerns?
Absolutely. When multiple parties are involved, ensuring everyone is playing fair and keeping the data private is a major challenge.
Right.
And this paper proposes this new federated learning method that utilizes clustering techniques and something called Intel SGX enclaves, which are these secure areas within a computer's processor. And this approach tries to reduce the amount of data that needs to be shared, minimizing the risk of exposure.
Okay. Synthetic data can mislead evaluations. Membership inference as machine text detection sounds pretty meta. Can you explain what this is all about?
Sure. So this study highlights a potential problem with using synthetic data to evaluate privacy risks in machine learning. Membership inference attacks try to figure out if a specific data point was used to train a model.
Gotcha.
And it can be really hard to create realistic data sets for testing these attacks. So researchers often use synthetic data as a substitute. But this paper found that these attacks often mistake synthetic data for training data.
Oh, so the synthetic data is too good.
Exactly. And it ends up making the evaluation results unreliable.
Okay, that makes sense. Oshir Abiye. Improved error-free asynchronous Byzantine agreement via partial vector agreement dives into distributed systems.
Right. Byzantine agreement is a classic problem in distributed computing. It's all about getting a group of computers to agree on something, even if some of them are malicious or faulty.
Right. And how does this research contribute to solving that?
This paper presents a new protocol for Byzantine agreement that works in asynchronous networks, which are networks where messages can be delayed or arrive out of order.
Okay.
Their key innovation is this technique called partial vector agreement, which allows the computers to agree on parts of a value, even if they can't agree on the whole thing.
Shadow genes. Leveraging recurring patterns within computational graphs for model genealogy sounds like it could have some interesting applications.
It does. This paper introduces a method for analyzing the computational graph of a machine learning model to figure out its architecture, type, and family.
What is a computational graph?
It's essentially a map of how data flows through the model, like a flowchart. And this method called shadow genes extracts unique patterns from this graph to create a kind of signature for the model.
So it's like identifying the model based on its unique characteristics.
Exactly. And this can help us understand the model's capabilities and potential security risks.
Right. Cross-entropy attacks to language models via rare event simulation focuses on attacks against language models.
Right. So these attacks target models that are trained using cross-entropy optimization, which is a way of measuring how well a model predicts the correct output. And these attacks try to find inputs that make the model perform as poorly as possible.
Gotcha. And how do the researchers go about finding these bad inputs?
They use a technique called rare event simulation, which is a way of estimating the probability of things that are very unlikely to happen.
Okay.
And it turns out this technique is very effective at finding inputs that fool the model.
Interesting. With great backbones comes great adversarial transferability. Talks about the security of pre-trained models.
Yes, pre-trained models are kind of like building blocks for a lot of machine learning systems. And this research looks at whether attacks against these pre-trained components can transfer to the models built on top of them.
So like a vulnerability in the foundation affecting the whole building?
Exactly. And unfortunately, they found that these attacks can be very effective even if the attacker doesn't know much about the specific model that was built using the pre-trained component.
That's not good. Measured hockey stick divergence and its applications to quantum pufferfish privacy sounds very technical.
It is. It introduces a new way of measuring privacy that's specifically designed for quantum systems.
Okay, why do we need a special way of measuring privacy for quantum systems?
Well, in the quantum world, just observing something can change it. So traditional ways of measuring privacy might not work very well.
Right, a unified view of IoT and CPS, security and privacy, looks at the big picture of security and privacy in the Internet of Things and cyber-physical systems.
Yeah, the IoT is all about connecting everyday devices to the internet, while cyber-physical systems are systems that interact with the physical world, like self-driving cars.
Okay.
And this paper provides a framework for thinking about the security and privacy risks in both of these domains.
Differential area analysis for ransomware, attacks, countermeasures, and limitations explores the fight against ransomware.
Right, so ransomware is a type of malware that encrypts your files and demands a ransom to get them back. Differential area analysis, or DAA, is a technique for trying to tell the difference between files that have been encrypted by ransomware and files that have been encrypted for other reasons.
Gotcha.
And this paper looks at the strengths and weaknesses of DAA, and it even proposes some new attacks and countermeasures.
It sounds like a constant battle. ESAS-CF, Expertise, Extraction, Generalization, and Reply Framework for an Optimized Automation of Network Security Compliance, proposes automating security compliance checks.
Yeah, so traditionally these checks have been done manually by security experts, which can be time-consuming and error-prone. And this new framework uses machine learning to try to automate this process.
So it's like having an AI security auditor.
Exactly.
In our final paper, an anonymous yet accountable contract wallet system using account abstraction explores privacy and accountability in cryptocurrency wallets.
Right. Cryptocurrency users often want to keep their transactions private, but we also need ways to prevent illegal activities.
Right, so how do we balance those two needs?
Well, this paper proposes a new wallet system that uses something called account abstraction and accountable ring signatures. And this allows users to keep their transactions private, but it also provides a way to hold people accountable if they do something wrong.
That sounds like a really promising approach.
Yeah.
Well, that concludes our deep dive into the latest cybersecurity research. It's been a fascinating journey exploring all these different facets of this ever-evolving field.
It really has. From the looming threat of quantum computers to the creative ways researchers are using AI to enhance security, it's clear that the quest for a more secure digital world is a continuous process.
Absolutely. And thanks to all this incredible research, we're getting closer to that goal every day. Thanks for joining us on the deep dive.
Until next time.